Alright, so today we are talking about angles of elevation and depression, and it's based on what our prior knowledge is. And we're just going to kind of fill out some notes here, and then we'll talk about some examples on the next page. And this is a pretty easy, straightforward, quick section actually. Angles of elevation are the angles formed by a horizontal line. By the way, the most important thing of all of this is all of these angles, matter of fact, let's write it at the top, all angles start, capital, from a straight horizontal line that looks like that. Okay? Now, straight horizontal line. And the line of sight, of course, above would be angle of elevation. So from the horizontal line looking upward. And so, when we're going to fill that in kind of down here, what that looks like. The angle of depression is from a horizontal line. Again, they all start from a straight horizontal line to the angle of sight, to the line of sight, excuse me, of an object below the horizontal line. So looking downward. Okay? So, a horizontal line looking down is an angle of depression. A horizontal line looking up is an angle of elevation. So what I want you to do here is determine, well, let's name these things. Let's name this guy, this is the airplane, this is the tower, and this is the guy. And what I want you to do is take a second and just in between these blanks, you're going to write depression or elevation in this column, and you're going to write airplane, tower, or guy in these two columns. Try it a second, look at what it's asking to do, compare it to up above. Okay? Sorry, you can't see what I just circled. So again, look at what we wrote up above, and in this column you're going to write elevation or depression. Here you're going to write plane, tower, or guy in each of these blanks. Try that a second, pause it, come back. So one is an angle of depression, because again it is from the plane looking downward. So plane to tower. Angle 2 is from the tower, the straight line at the tower looking upward. So that is an elevation from the tower to the plane. Angle 3 is from the tower down to the guy looking down. So that would be also depression. And then angle 4 is from the straight line at the guy's line of sight up to the tower, and if he's going up to it, that's an elevation. Simple as that, guys. Next page is just some kind of story problems type stuff. You're going to see some of this it's already set up for you, half of the homework, the other half is like story problems. I think if it's set up, then realistically on this homework page you just use SOHCAHTOA all the way through it. So I thought I would just going to give you examples of these, and you need to draw pictures when there is no picture given to you. A surveyor stands 200 feet from a building and measures its height with a 5 feet tall theodolite. If you don't know what a theodolite is, you've seen it. They're on the side of the road. Surveyors, what is their name? Engineers, they use them to basically survey traffic and see, you've seen them, they all set up a tripod and it's usually like a yellow camera looking apparatus. That is a theodolite. The angle of elevation to the top of the building is 35 degrees. How tall is the building? Well, let's draw it out first. So I've got my building. Don't judge me, I am not an artist. Okay, and I've got a guy standing over here with his theodolite. So I'm going to put a theodolite over here on a tripod. Yeah, again, I'm not an artist. And I'm a certain distance from the building. Of course, I've got this part of the building. And I'm looking up. It says the angle of elevation. So that's this from a horizontal line looking up. It is not this. Some of you are going to struggle with that. That angle is 35 degrees, the angle of elevation from the horizontal line upward. How tall is the building? So I want to know what this length is. Well, I also know my distance here is 200 feet. It tells me right in the problem. So now that I have it labeled, I can go and work it out. From here, from this angle, I have the hypotenuse here, because that's a 90-degree angle. This is the side opposite. This is the side adjacent. So I'm going to need tangent here of 35 degrees equals opposite over adjacent. Of course, when the number's up high, you multiply. When the letter's up high, you multiply. So x equals 200 times tangent 35. Please do not go tan 35 times 200. It'll multiply the 35 and the 200. You won't get an accurate answer. I do this, and you'll see it's about 140 feet. But then we start saying, okay, so that's the answer here. Except, is that the full height of the building? Well, no, because we had this theodolite that was 5 feet off the ground. So the distance here is 140, but the distance here is 5. And so to get the answer, which here is no, because of 5 foot theodolite. It's just fun to say, isn't it? So it would be 140, again plus 5, to mean the building is 145 feet. You must label in these, ladies and gentlemen. You will lose a full point if you do not label. They are story problems. You should be used to that by now. Now, an airplane right here sees a life raft right here. We'll just draw ourselves a little raft here. Yay. At 26-degree angle of depression. Now again, this cannot be your angle. That cannot be your angle. Why? Because it's not starting from a horizontal line. This is starting from a horizontal line. So we can maybe think about that, but angle of depression is from a line looking downwards, from a horizontal line looking downwards. So our 26 degrees goes right there. The airplane's height above the water is 3 kilometers. So we can measure this with 3 kilometers there. What's the surface distance? Distance is always horizontal. If I travel in a car, I drive horizontally. I drive like that. If I'm driving up a hill, the distance is still the horizontal distance. So don't think of this right here. This is not x. We'll talk about when that is x in just a few minutes. What's the airplane surface distance? So we're trying to find this. Again, I have opposite over adjacent, so I'm going to use tangent again. Opposite over adjacent. Now I got the letter down low, so I need to divide 3 by tangent 26. If you haven't noticed, anytime you have to divide, the trig function always goes on the bottom. And I'm going to get about 6.2 kilometers. Is that the actual distance? Yes. 3 meters up, it's on the ground, there's nothing to add here. Okay? Let's go on to the next problem. Okay? This person standing 30 feet away from a flagpole, can see the top of the pole at a 35-degree angle of elevation. So I've got my guy here. Again, don't judge me, I'm not an artist. He is seeing the flagpole. Again, don't judge me. Good enough. And this is not to scale at all, but I know that I'm seeing the top of the flagpole from where I'm at a 35-degree angle. Again, that angle does not go here because it is not starting from a straight line. Now, if I'm standing 30 feet away, there's 30 feet right there, and I want to see how tall is this flagpole. Again, it's not to scale, but again, what I need is this length. Tangent of 35. It is not always tangent. It just happens to be in all of our examples. X over 30. Letters up high, you multiply. And you get 21 feet. Now again, if that person's level is 5 feet further, like it's saying here, well, I need to add, 21 plus 5 to get 26 feet. Okay. Things to remember. When do I label that? Well, X is the diagonal if and only if it is tangible. The word tangible means I can touch it. In other words, some examples. A road, a ladder, you're going to see that. A tree, you're going to see that. A ramp, or a kite string. These are the examples of stuff you're going to see that you can touch. Then X goes on the hypotenuse. Then, of course, you're going to use sine or cosine one way or another, right? A couple things to remember is distance is always, set this up above, a horizontal measurement. Okay, and height is always a vertical measurement. Think about it. If you're asking your height, you would never say you're 3 foot long. You'd say you're 3 foot tall. Okay. The only other thing, so that's the notes, that's it. The only other thing is, on this page, again, you're just going to go through and you're going to fill in what it is, okay? Let me go back here and make sure this is on camera, that you see that, just in case I didn't put that before. On the next page, you need one little helpful hint on number 9. It says, during a violent thunderstorm, a tree broke down. How tall is the tree, basically? What you need to consider is, your tree is here, it breaks down to here, I don't know, put the rest of the tree here, okay? And you are going to need to find the height of that and add it together. You'll be able to label it according to what it's saying, and I can just complete this kind of as a triangle. Think about the length here plus the length here equals total tree, okay? And that's what the little hint here is about too. Your homework is 1 through 12. Have a good day.